everybody. Sorry for the delay. Slight technical difficulties there. We can write distributed systems, but we can't work PowerPoints. I am here to talk to you guys today about some Python usage with Phoenix. So a little bit about me. I am a recent engineering manager at Hortonworks. So I'm in charge of the HBase and Phoenix team loosely. Sometimes that includes other fun things like Zookeeper and all sorts of other fun stuff. I was recently tricked, volunteered, suggested to become the VP of Apache Phoenix. So I'm now a glorified secretary for the project as well. I'm a member of the Apache Software Foundation, which means that I've done enough stuff to make people think that I know what I'm doing inside the Apache Software Foundation. And sometimes I like to actually get outside and do some other stuff as well. Involved with a number of different projects over the years. Some of these I still contribute to. Some of them I don't as much anymore. And we have a couple other incubator projects I've been involved with time after time. Slider is probably the most successful of that now, which I can happily say is actually up in the Hadoop Yarn project now, which is really exciting. So today we're going to talk about Python and how it relates to Phoenix. To talk about that, we kind of have to back up a little bit and talk about the Phoenix query server. So how many of you know what I mean or what I'm referring to when I say the Phoenix query server? Show of hands. That's probably the best I've ever had. I've been giving talks about it for off and on the past few years, so it's exciting now. I think we actually have like majority in the room who know actually what I'm about to tell you about. So it's exciting. Slightly fewer glaze over eyes in the room. So the Phoenix query server is really nothing else other than a very glorified gateway for JDBC drivers. So it is a proxy that sits in between your client and the database, and it provides a whole bunch of things that are nice to have in sort of a real-life production deployment. So we have things like authentication, we have authorization, we have most importantly, probably a cross-version compatible wire API. So what that really means is that when we have multiple versions of the Phoenix query server, in the most cases, one version of a client is going to continue to work against future versions, and we do a lot of work there to make sure that actually happens. We have a lot of great work recently, actually, from some friends at Salesforce who have started contributing some other work. So I'm also happy to say it's not just me working on this anymore. Excellent. And there's a bunch of other stuff that we want to do with this in the future. There's some natural synergies with things like Apache Knox, acting as a gateway. I always want to see more happening with using some out-of-the-box load balancers like HA proxy or Nginx, stuff like that. Annie's talk, I remember talking to Annie who did the one previously about PQS and Ignite from Bloomberg, if you guys caught that. How can we embed PQS inside of app servers, like your JBoss, Wildfly, whatever they call it now, stuff like that. And also, how do you, if you deploy this, how could you find it easily in a cluster without knowing a static host name or something where it's located? So again, like I said, your traditional model, it's, clients talk to region servers, talk to HDFS. We all should know this pretty well. And PQS is a proxy and sitting in between your client and HBase, so it's simplifying the architecture. You don't have to ask, you don't have to open up a firewall. A client doesn't have to talk to every single region server in the cluster. You can just go and talk to one single point, simplifies deployments. To an extent, it also acts as a single point of failure, but we know we can scale out the PQS. We can run multiple instances, so that mostly makes us happy that that's not a real big issue for us. So I mentioned earlier, client compatibility and having a stable wire API is really important for us. So one of the reasons we like that is obviously that we don't have to keep fixing our broken code anytime we update. The other side is that by having a stable API, it lets us able to write other types of clients. So presumably, this is a Java-based project, Phoenix, obviously, as you all know. If we didn't have a stable API, every time we made a change, it would result in a lot of headache for everybody else downstream. And eventually, they would probably just go and say, hey, man, I'm sick of you always changing this API, and you always make me change my code every single release. I'm going to stop doing this. So this is really important for us to harp on. And we actually, I tried to write a bunch of testing inside of PQS itself, Avatica, the base project that we have a lot of this code in, to really put some clout behind these words. Make sure that, no, we aren't just saying it's compatibility. We actually have some tests to back this up. So that sort of brings us to Python, right? So Python, it actually came up from a guy, I have not yet met him yet, Lucas Lelinski. I think he might be in Europe somewhere. I'm not exactly sure. He's one of these guys who just kind of came out of the woodwork and keeps seeing his name over and over again. And then one day he's like, oh, I wrote this Python adapter. And he put it up on Bitbucket, and we were all like, wait, you did what? And we look at it and like, oh, you really wrote a Python driver. That's pretty sick. So this was back in like 2015, 2014, 2015, somewhere around there. This was very early on, and we were just trying to make this PQS thing, you know. So when I would have asked that same question, maybe 2 or 3 of you would have raised your hand and go, oh yeah, I know what that is. So it was actually one of the first ones, the first non-Java drivers for PQS that I know about. We're now up to a few. Microsoft, some guys at Microsoft wrote a .NET driver, and another random person wrote one in Go language. Go is actually committed up in the Avatica repository, which is pretty darn cool. .NET's just sitting out on GitHub. But with Python, what we really want to do is try to make this as an exemplar to say, how do we really bring this into the Phoenix community? And you might be asking yourself, you know, Josh, you know, well, why do I give a crap about this? You know, why do I care about this? We haven't had any other drivers for other languages, you know, what's the big deal? So, you know, if you make the analogy right, we have Phoenix, and it provides JDBC, and you know, and JDBC and all well, and is a great hammer, right? We have our toolbox, and when we see a problem, we open our toolbox and we bring out a hammer, and you know, and most of the time we have something that looks like a nail, and we pound the heck out of that nail, and we say, yeah, I pounded that nail really good, you know, like you. And we get in this place where like, yeah, this is cool, you know, we know how to go, and we can use Java, and we can use JDBC, and we know how to solve our problems. And then some days we see different types of problems. We're like, well, that kind of looks like a nail, you know. Maybe, and you just get to the point. It's like it just doesn't work, and we spend a lot more time, We're spending more and more of our own time to try to solve a problem, which just isn't a natural fit for what we have in Java. So the sort of stereotypical things where it's very verbose, very pedantic. You're spending a lot of time just writing boilerplate to get a job done. So the reason I really am excited about the Python stuff here is that this gives us a solution that lets us iterate a lot faster without changing how we're accessing Phoenix. Phoenix feels exactly the same. We're not using any different syntax. We just have a Python API for going and doing this now. So the implementation, what this really looks like, is Python as a community has these things called PEPs, and these are specifications for how things work in Python. So PEP 249 defines a database API. So very standard thing, all your standard databases, SQLite, MySQL, Postgres, they all implement this API. In traditional Python stance, there are other ones such as like SQL Alchemy that you can use to also access the database, but for now we have this Python DB 2.0 API. And essentially how this driver works is that there's an API that takes the wire protocol that PQS speaks, that well-defined protobuf-based API, and it implements this. The transport is HTTP talking to PQS, and then we're just exposing a Python API on top of that. So if you guys can read that there, it's a little blurry there, but essentially we have a cursor, we execute some SQL, we have the ability to create a unbound statement, so we have some values that we're going to late bind into the SQL. We can generate some, we have an array of, a list of values there. Those are going to be late bound into the query submitted to the server. Very standard stuff that you'd expect from a prepared statement in Java via JDBC. Very simple, and then we just verify we get those results back out. And at face value, like, yeah, okay, yep, I could do that. And the same sort of thing, you know, this is nothing really outstanding here. You know, we have some list comprehension here. We're generating some stuff. We're doing slightly more, slightly fancier upsert with values, and it's cool. But the thing that really tickled my fancy, and a lot more than I really expected it to, was when I started looking at what else can I do with Python, right? Now that I have this thing that just standard works in Python, what else can I do with it, right? So I went back to my college years and said, hey, I'm going to write a web app, right? I can go and make a little CRUD web app, and I can do this with, Phoenix as a database. Why don't I use it like a database? Well, let's go back to Web 2.0. So if you don't know, Flask is in their words about themselves, a micro framework for Python based on WorkZug, Jinja 2, templating engine, and good intentions. I'm not sure what the good intentions part means, but we'll just skip over that. But very simple if you ever want to write a web app in Python. It'll literally, like 6 lines of code there on the left, defines a REST endpoint, you hit it, throws up a web server, you get back that text. Very dumb, simple. Ultimately 3 lines of code there to install and run. And what I did is Flask has a little tutorial that you can make a blog out of it. And just walking through, they do a very 15-step thing. You go and what it did in like an hour and a half or something, me not having used Flask for any real programming, I turned around a web app that was creating, updating, deleting blog posts with user authentication in an hour and a half using Phoenix. This blows my mind that I could go and do this. This was the coolest thing I have done in probably a couple years. It's blew my mind. Exact same database that we are all knowing and loving, everything about HBase and Phoenix that we all like, and now I had a brand new way to start using this tech that just felt absolutely great. All these things that are already baked into this framework, all these really nice things about using Flask and doing session management via Flask, all these really nice features and stuff built into this library, I didn't have to rebuild a single bit of it, and it was awesome. And at the end of the day, the code was absolutely trivial, right? So here I'm setting up the framework inside of Flask. I'm defining my database, and then I'm caching that database inside of this long-running application object that Flask has in the actual Python project or process. And it's simple. I open a database. I say when I'm getting a row out of the database, I'm going to map it to a Python dictionary, and then I'm defining how I close the database. And then I can make these really simple things like how do I update a post in my blog. I can go and I can say, if I get a post request, I'm going to rip out a title and a body. I'm going to take that, I'm going to translate it, I'm going to upsert values of that data into my blog post table, and I'm going to join that based off of I'm also going to pull the user ID out of the active session from my logged in state, which was authenticated against the user table, a second table I had in Phoenix, and I go and insert it, and that was it, and it just worked, and it blew my mind. It was so exciting here to see this, what felt like old hat technology now, suddenly just have this breath of new life that I can go and do something new and exciting with. So I thought to myself, I'm all right, that was pretty fun. What else can I do? So I again went back to my college days and I said, okay, well, what else did I do with Python college? And I was okay, I used that Beautiful Soup thing. So Beautiful Soup is another well-known Python library. I think there's probably something newer and sexier than this by now, but this is what I used. But essentially, it's a very nice parsing library that helps you rip apart unstructured or poorly structured text. So it's very good at scraping HTML. You get a very nice XPath-like sort of thing. You can say, give me all divs in paragraphs with anchors and stuff like that. And again, in typical Python stance, it's dirt simple to go and take an HTML doc and just parse it. So, I had the idea of, well, okay, can I go and make a web crawler that stores data inside of Phoenix? That should be pretty cool, right? And then I could do things like PageRank or something on it if I start ripping out links from each web page. Same sort of thing here. In this case here, I'm doing something pretty dirt simple, just doing a schema management. I can go, I want to set up my tables before I go in, so I can go and drop any tables that exist, recreate them with my schema, easy peasy. I can then go and I can go to a single website. I can go and fetch the data from that website, pull down that HTML, throw it into Beautiful Soup here, which will parse it out to me and just say, give me all the anchors from this page. Then when I'm done here, what I can do is I can insert one sort of blob into a table in Phoenix that just says, here's the content of the table and when I scraped it. And then for another table, I essentially just have a 2-column table where they're in the primary key. So essentially I have website A has a link to website B, right? So dirt simple, that's the exact structure you need to do something like a PageRank algorithm to start figuring out the popularity of websites. And when I'm done, go and run this stupid little crawler over my own website, 30 pages or something at the most. Then I can go and let's say, I'm going to run a query and just say, what are the number of outbound links I have on each page? Dirt simple. This comes back. It's a trivial amount of data, but at the end of the day, this is still the same functional amount of data, or this is the same functional product, Phoenix. I'm just using in this brand new and different way. So in my mind, this was a very trivial sort of application of what I'm doing, but the potential for what this really means is really freaking cool. So I'm scraping the surface here of kiddie applications, what you can do in an hour and a half, but what about if you want to do something else? Like say, you can use the Python pill, the imaging library they have. It's very well known for doing programmatic, scraping and processing of images stuff. What if you start storing raw image data into a Phoenix table backed by HBase mob, so you're not bloating up your H files, and you go and you start doing analytics on these images you have in here. Same exact thing. You can still do any sort of heavy processing you want to do via Java or MapReduce, but you can now go and do it in these other libraries and take advantage of this very well-known parsing library. You can start doing numerical computations and more mathy stuff via NumPy or SciPy. You can start doing some basic graphing stuff with Matplotlib or GNUplot, stuff like that. You could start writing a native Linux application using GTK or Qt. You could even go and do stuff with pandas. Pandas is another one of these new sexiness things that I'm too old and curmudgeon-y to start using yet. But it's not really meant to be much more than this, but the applications now of what we really have enabled by the Phoenix Query Server are really kind of exciting because we've sort of shown that we can actually take this, this new process we have here and really build on top of what it means to run Phoenix and what we let our users do. Via opening this sort of door here, we're now going up to people and saying, you don't have to use Java to access the data in Phoenix and HBase. That's no longer the story we have to tell. It's really now, what drivers do we have to talk to the Phoenix Query Server? And you go and implement whatever you'd like to do in your language of choice. So that's really all I had. I'm probably a little over given our technical difficulties, but I'll take a question or two if we have time, and otherwise I'll let the next speakers come on. For the most part, so the question was how many query servers do we run? For the most part, one will suffice for most ad hoc use cases. I think most of the time it's not gained enough confidence that people will deploy it to a production. There are some limitations, especially around Kerberos, in actually making a well-vetted, highly available deployment. So there's some stuff around how do you actually do this Spinego authentication correctly sitting behind a load balancer. And there's just, I don't think there's any technical challenges. We've just done a poor job at actually advertising this is how you would do it in the field. But for the most part, with a beefy box that we're seeing in the field and a decent Java heap, one is enough for most use cases. I think if you put that directly user-facing some real-life workload, it'd be a different story. But for the most part, one, it's been sufficient for us. All right, if you have any other questions, get me afterwards, and I'll kick it over to these guys.